Let us at what? Rate what? Rate curve. So the rate curve can be obtained by plotting the concentration of reactants or products with what? With time. And is what? This can be obtained by plotting concentration of reactants or products with time. So let us look at this. So if you have what? A reaction that comprises of A and B, they add together to give us what? C plus what? D. We know that what? This A and B is called what? Reactants. And this what? C plus D, they are products. We are now asked to what? To plot the graph, the rate curve of the what? Of the equation. So on the vertical axis here, we have concentration in what? Mole per dm cube against time in what? In seconds. So if you plot the graph, your curve will come like this. This one is called what? Product curve. And this will come like this. This is what we call what? Reactant curve. So what is my product here from this equation? My product here is what? C plus what? D. Here we have what? A plus what? B. So whenever you are asked to plot the what? Graph of what? Rate curve of any equation, this curve represents what? Product, where this represents what? Reactant. But let me explain. Why is it that what? This one has moved like this? This give us product, this give us what? Reactant. If you could still remember in a particle kinematics in physics, see, any graph that is have a positive what? A positive slope must start from origin and move up like this. So, but any graph that is have a negative what? Negative slope come like this. So you can see that what? This positive slope represents what? The product. The negative slope represents the what? The reactant. But if you remember or you write out the rate equation for this expression, no, I said it earlier that the rate for this expression will be what? The rate for reactant will be minus conc of A, conc of what? Of B over what? Over time. For rate for product will be what? R will be what? Conc of what? C, conc of what? Of D over what? Time. Or we have a plus. So the presence of what? Of minus as the rate equation for what? For reactant, make the curve of reaction be what? To come down like this, negative slope. The presence of the what? Of positive we have in the rate equation for what? For product, make it to be what? To be increased from the origin like this to have this curve. So when we get to the what? The graph of acid, base, and salt under titration, I will explain this particular point here, where this curve here is what? It's constant. Move like this. Is the point, this point here, we call it what? End what? End point. So I will explain the endpoint in an acid-base titration curve. So for now, just know that what this is what the curve for rate of what? Chemical reaction. So let's solve question on it. Example. Yes. Which of the following curve represents formation of oxygen from thermal decomposition of KClO3. P, Q, R, X. Option A. KClO3. This is the equation of reaction. Thermal decomposition. What? KCl plus 3O what? 2. We have what? 2 here. This is the equation of reaction, no? Option A. We have P, option B, Q, option C, R, option D, X. Assume we are that what which of the following curve represents the formation of what of oxygen from thermal decomposition of what of KClO3 to give us what KCl and what oxygen. Look at the equation of reaction. First, in reactant site, what do we have here? KCl what O3 is a reactant, Abi. So everything you have here are what? They are what? Reactants. And Abi, and everything you have here, they are what? Products. So at the product side, we have potassium chloride and oxygen gas. You are now asked that what? Which of the curve represent what? The oxygen. Look at this oxygen here. It can be found in what? At product, not in what? Reactant. So since oxygen can be found in what? In the product side of the what? Of the equation, therefore, which of the curve here represents the product side? So check it related with this one. This is product curve. This is a reactant curve. Abi, and oxygen can be found at what? At the product side. So which of the curve represents what? Oxygen. If you check it, P is not product curve. R, the straight line, is not product curve. X is not product curve. The right answer here is the what? Will be Q. Q is what? The right answer. So answer is what? Option B. Or let me bring another question again. Example 2. Which of the curve represents thermal decomposition of Kakotiri? What do you have Kakotiri? Kakotiri is what? CH3 decomposed to give us what? Calcium oxide plus oxygen. Put 2 here balance, 2 balance. Here they are talking of what? The breaking down of what? Of Kakotiri. So assume we are given this what? The graph. This is the graph. Concentration against what? Against time. So we have option what? P, Q, R, S again. So we now have the first option A, P. Second option R, Q. Third option R. D is what? Is X. Which of the curve represents the composition of what? Of Kakotiri? The calcium carbonate can be found at the product site, at the reactant site. So which of these curve represents reactant curve? By applying this. So the reactant is this one now. Abi? Yes. There is a mistake here. P, Q, R. So you now look at this curve. Which one is what? The same with what? With this for reactant. And then we have calcium carbonate here. It will give us what? Calcium oxide and carbon dioxide is not oxygen. So we want to ask which of the curve represent the what? The decomposition of Kakotiri. Kakotiri we have it at what? Which is calcium carbonate at what? At reactant site. So which of these curve represent the reactant? It is P, it is P or Q or R or X. So if we look at it now, this is the only X that is the same thing with what? Reactant. So our right option here is what? Is D. That's how they used to what? To test for rate curve in multiple choice exam, particularly in our Nigeria here, in CBT exam in any university in Nigeria, or in UTME exam. That's how what they used to test for the rate curve. But if it is theory, they will give you, they ask you what? Draw the rate curve. We have to draw it. This is the rate curve. This one for the reactant. This one for what? For the product. So let us look at the next aspects of rate of chemical reaction.